Now with our last session, Dr. Monserrat Sofia Lopez, material engineer and professor in the material engineering department at ITM, will talk with us about Tele Challenge 17. Please, Dr. Monserrat, you can start now.
Hi, everyone. Thank you. Good morning or good afternoon, depending where you are. It is a pleasure for me to present this contest. And first of all, I will personally thank the invitation to the SOS University student chapter. I really think that this is a good opportunity to networking between student chapters. I know that you are very active, and congratulations for the award you received as the most outstanding chapter for material advantage. And congratulations to all the speakers before me. I think that this kind of event, it's really important for everyone. Sometimes we are related to metallurgy, but as material engineers, we need to learn a lot of other things. And actually, the Steel Challenge, it's a contest organized by World Steel Association and Steel University. And I would like to talk about that because it is the opportunity to apply all your knowledge that you acquire in the university and then challenge the the knowledge to other students from other countries. And I'm going to start to talk about some associations that you must be there. And as you may know, as you are a student chapter from Material Advantage, as well as some others that maybe are here as students, the Association for Iron and Steel Technology, it's a worldwide association who's looking to connect the students with the industry. But actually, the World Steel Association has a similar mission. It's one of the largest and most dynamic industry associations with members from all over the world. Around 85% of the global steel production are members of this association, and they are looking for promote the steel industry and the steel as material, find global solutions to the environment challenge, and analyze important mega trends, as you may know, all related to energy and how to lower the emissions of carbon dioxide, encourage alignment between the regional and national steel associations. And as part of their mission, they have a web page, as maybe you have the opportunity to access. This is Steel University. If you don't know Steel University, I do recommend you to access to all the training seminars, the webinars that they offer to students and to steel professionals, because this initiative by World Steel Association is trying to training the future employees. You definitely are the future of the steel industry. So you can take as many courses as you want. Some of them have a cost, some of them are for free. For example, the introduction to steel. I used to use this course, this training seminar for the freshman students at the university. I forgot to mention it that I was so excited and I forgot to mention I'm an assistant professor at Instituto Tecnológico de Morelia, and actually we have a very active student chapter, the AIST-ITM. And as we are in love with the steel, we always try to participate in activities as the Steel Challenge, organized by, as mentioned, Steel University and World Steel Association. Introduction to Steel, it's a very good training seminar to everyone who is starting his career related to materials engineering, or maybe you want to, I don't know, prove your knowledge and try to understand, or maybe to explain to someone at your school, or to explain to the K-12 community and thought about the steel. This definitely is the training seminar. And then you can find another ones related to processes, steel processes, and not just iron, but it's more about the steel. And they organize every year the Steel Challenge. This is a regional and a worldwide championship where you can use all your knowledge related to the steel making. It depends. It could be 1 year can be the BOF, 1 year can be the EFF. It depends of they decide the kind of process that you're gonna simulate in their simulators, but it is very interesting because there are two categories, the industry and the student. And you can register to participate first to participate in the regional championship and then to the worldwide competition. And in the regional section of the regional championship, as if you are a student from Mexico or from US, from Canada, or from another country in Latin America, you will find your region in just one section. If you are from Europe and Africa, you will be participating with all the countries from those continents. It depends. It's very competitive, to be honest, because it used to be in some other regions, and now you are competing with a lot of countries. But trust me, if you practice before the competition, you have the great opportunity to learn first of all. But then if you won the regional championship, to represent not just only your university, but also your country and your continent. Asia North, Asia West, and Asia East and Oceania, as you may know. Well, there are a lot of people living there, so that's why they separate the regions. But you have around, if you have never heard about the Steel Challenge, right now you have around 1 month to prepare to participate in this competition. As you can see, the schedule, it starts at June, just for the call of for sponsorship. Some of the biggest companies of steelmaking are participating, and the online registration started the last September. But you still have time to take the master classes that are related to the electric arc furnace steelmaking, to the reduce of the consumption of energy, the introduction to the simulators. All of them are for free. If you have not registered to this contest, you have access to the masterclass to know about what is related to this. How can you find the simulators? Maybe understand why you have to participate, and then this is the most important date. 16 November is the regional championship. It starts at 12 UTC and it's about 22 hours. I say about because sometimes when the competition is on and there are so many results and maybe there's a tie, they sometimes give 1 or 2 hours more. Still University decides to continue with the competition just to find the first place. So it depends. Some years there are just 20 hours. Some years, some competitions, they take 2 hours or more. But consider all the day to be in the competition and to have time to start with the simulators. Actually, the simulators are very simple, and you definitely have to take classes here in Mexico, in Morelia. For example, the all the related to the ladle metallurgy. It's in we used to teach it in one class, and not related to the electric arc furnace, the basic oxygen furnace, the blast furnace. It's in another subject. But if you register to this training, you have access actually to the training courses. They are very good. If you maybe still don't understand so much about this all this process, and definitely you will learn about it. And finally, 18 April in 2023 is the World Championship and the award ceremony in Vienna with the World Steel Board of Members. So the participation is individual. Some years ago it used to be in teams, but right now you can work with your classmates if you want to. You can arrange a team, but there is only one winner. by region. So you have to understand that, and the participation and the registration is just by a student. Actually, this category, I'm going to talk about a little more about that, because if you are doing, we call it here in Mexico, or professional practices, your internships. If you are working right now with a steel industry, you have to be enrolled in the industry registration. If you are a full part-time or temporary work term, you can register as a student category. But maybe if you are in that process when the company is trying to convince you to work with them, you have to be in another category. The student category is for individuals who are enrolled in an academic institution at the time of the registration period. And there is difference between the case, because you have to, actually you can choose the steel rate. You have a steel university chooses a steel rate to all of all the students that are participating in the challenge. But for the industry section, the industry category, there is another kind of steel grade, and also there are more features related to the process. So it kind of changes. It is expected that as a student, maybe you don't have the experience. This is a really good opportunity to experience a close up to the real process. But if you are in the industry category, you definitely have seen operate a electrical furnace, and you know more about that. So that's it. That's maybe some of the things that sometimes change, and maybe it's a challenge, or yeah, kind of, if you are in the another category. But as I'm mentioning, as a part of the different points, or considering what is the first step. If you want to participate, you have to register, choose a faculty advisor, use your email, and then choose the region where you are participating. Then you have, as I mentioned it, right now, if you go to the steeluniversity.com website, you have around a month to play and learn, because your registration includes learning the training courses to understand the kit that you have to simulate right now. The steel grade that Steel University chooses to practice, it's not gonna be the same for the competition, but it's pretty close to the grade, the steel grade that they're gonna use in the challenge. So at least you have the opportunity to know the simulator, how it works, what kind of scrap can you use, what kind of dolomite, lime, the quantities, and first of all, the cost, because this is the most important part of the challenge. As I mentioned, the regional championship, you can win cash prizes, and the I think that the most important is that you can participate in the world championship and then go as the world's best steel maker. So how is the challenge? Well, this year, steel universities choose the electric arc furnace and secondary steelmaking simulators. These are integrated. You have to produce a heat at the arc furnace, and this heat with the composition, the steel chemical composition and the slag chemical composition, it will be the same that you're going to use in the next stage, the secondary steelmaking, as it happens in the real life. So if it also has a cost. This cost, as you may know, increases. It's not the same when you just melt all the scrap, and now after that you go to secondary steelmaking, and then you adjust all the chemical composition. Or maybe you add argon stearin, or maybe you heat you control the temperature in the heat. Some other features that definitely will take a part in the total cost. So the simulators for the competition are, as I mentioned, are able for practices, but it's not the same heat. Then the competitors are tasked to produce a greatest of steel meeting technical requirements at the lowest cost per ton. This is actually the principal task for you, the lowest cost per ton. You are gonna be asked for, of course, a slag chemical composition that it fits with the one that they asked you for. The steel chemical composition, you have to reach also a temperature in a range temperature at time, because it varies, but as you may know, the time that it takes to melt the scrap in the electrical furnace, it varies, but it has to be in a time to then go to the next stage and finally go to the continuous casting section. So you have to take in account a slag chemical composition, a steel chemical composition, the time for the heat, the time, then the tons, because you have to use the same amount. You can use a scrap, you can use the ARI, but you have to produce a heat with a 80 tons per heat. So that this is only a highlight, or at least a demand for the competition. And then you have to be at temperature. I mean, I forgot about that. The temperature, you have to be in that range. So that range, sorry. So a grade of steel is designed for the regional championship, and then if you go to the next stage, you will challenge to a different kind of steel grade, but the simulators are the same. Actually, the simulator is simplified. You may use oxygen injection, you may use carbon injection, you may use the additions of limes, of ferroalloys, but you don't use burners, for example. You don't use another features or state of art technologies, as you saw the last in one of the presentations with engineer Hannah, that he mentioned the con steel and some other technologies. They are not featured here in the contest. It is a simple electric arc furnace. So it contains some deviation from the actual operator practice, but I told you it could change, definitely. It depends of the category, if you are in the student or if you are in the industry category. And remember the date, 16 November of 2022. The fee for the registration depends of the category. If you're a student, you have to pay actually for 14 euros, 14.498 euros. If you are an industry professional, it almost is the double of the fee. But the good news is, if you pay this fee, you have access to the electric arc furnace course, you have access to the secondary steel making course, and the simulators to practice, as well as the challenge and a certificate of participation. I do recommend to participate and to take as many courses as you can from Steel University, because all of them are really good, first of all, but it helps to your curriculum vitae. So you have to you should take it to increase your knowledge out. Also, if you want to know more about that, you can go to the website steeluniversity.org and to learn more about the Steel Challenge. I will try to explain as the maybe I don't have so many time as I thought, but I will try to explain a little bit about how the simulator works. As you also had the opportunity to review in the last presentations, there are two main routes to produce steel: the basic oxygen furnace and the electric arc furnace. It depends of the first of all, I think that the main difference is the cost, and of course the kind of raw materials that you use and the energy. Maybe I'm just saying like the ABC of metallurgy, but maybe some of you are still learning about the processes. So in the basic oxygen furnace, we use oxygen to produce the energy to melt the scrap and the pig iron. And in the electrical furnace, we use electricity to melt the scrap, the DRI, and the briquettes and some other metal sources that we need to. Both of them have the next stage after the melting of the scrap is the refining in the metallurgy station. It could be it depends if you need vacuum or you need another feature to increase the quality of the steel. But all of them goes to continuous casting or maybe ingot casting. It depends on the product. So actually, just 29% of the steel produced in the world is produced via the electrical furnace route. Actually, it's as mentioned, it depends, because even there here in Mexico, for example, we have just two BOF active in NAMSA in ArcelorMittal, but even though the 71% of the steel is produced steel battery route. As you may know, you need a blast furnace to produce the steel using the BOF, and the cost tends to be lower compared to the electrical furnace route. Why? Because practically, I'm gonna skip because I wanna explain this slide. This is the cost. It's an average cost related to the electric arc furnace processes, and it's $638 dollars per ton to produce the steel, 1 ton of steel through the electrical furnace route. What is the most expensive, or the most expensive feature or material or item producing through the road? The steel scrap. This is the most important, and that's maybe this route is not so used. The steel scrap, it's not so common, and right now it's not so cheap. So this cost, it may change between the years and between the regions, depending of the available of the scrap. That's why some of the biggest companies are looking for another metal materials to use it in their processes. So this is definitely, maybe in the simulator you won't find the pig iron or DRI raw materials, because it can be used as DRI, but not the pig iron. Not the industrial gases, just as oxygen. It is also a cost related to the production. Ferroalloys, of course, fluxes, the limes, electrodes, the use of electrodes, and it related to the electricity. The newest point for this year, and no, actually, in the competition last year it was the same. The carbon dioxide emission is something that you have to control, and it is now a cost in the production of the steel through the road. You have to you can reach the 20,000 kilos, about 20 tons of carbon dioxide emission in order to complete the heat. If you don't mark that feature, then your heat is not valid. Labor and capital charge, you don't have to take it, and labor actually in the simulator it's due, but it's not considered in all the total cost. So I'm gonna I'm going to start to share with you a little bit about the simulator. I would like you to know about some of the features. When you register to the competition, you have access to a brief summary where they explain you. They ask you for your faculty advisor, your email, some of your principal data, and then you have access to the simulators to practice. If you want to, you can first go to the training seminars, and then go to the simulators. It depends. I mean, if you want to know how it works, we can go to the simulator, and when you start to finish all the hits, and all the hits has all the all the points that you need to check, then that hit, it's going to be available for all the time that you're using the simulator, and you have to have a price to know how it at the final. Before continuous casting, you will have the result of the hit, the date and time where you produce it, the price from the electric arc furnace, and the price in the secondary steel making, because the final cost, it is the combination of both of the process. They introduce you, it is the same when you are using the simulator in the competition. You have to mill raw materials. It doesn't say scrap, it says raw material, because you can use some DRI, or it depends on the kind of scrap that you want to use. It depends the residual chemical composition and the residual elements. That's some of the highlight points to cover. And you have to produce a heat between 80 and 110 tons of liquid steel to refine them in the next stage. And the tap to tap time should be less than 80 minutes, and the tapping temperature should be between 1630 Celsius degrees to 1660 Celsius degree. The results, as I told you, has to be measured by the cost per ton, the steel and slag chemical composition, and the time of you just have 80 minutes. If you are in Mexico, don't worry, you can use the Espanol feature, you can use the English and Russia and China. It starts with the kind of raw material that you're going to use. How, as a tip for you, if you want to start and you don't know how many, you knew that you have to use 80 tons. But the most important feature here is related to the elements, and to be more specific, to the residual elements. If you add scrap classified as plate and structural, and you use all the 80 tons for these matters, you will see that you have to add carbon, you have to reduce the silicon, you have to reduce the magnesium, the phosphorus, and you have to add chromium. But the problem here is that if you have as you see, the residual content related to molybdenum, nickel, niobium, copper, titanium. Titanium no, because you have zero actually, but copper, niobium, nickel, molybdenum. If you have a higher percent of the between the minimum and the maximum, you have the higher than the maximum, you can reduce none of these elements when you are melting. That's the some of the classmates mentioning last. That's the game. That at the beginning of the simulator, you definitely have to choose the right kind of scrap, because if you add 80 tons of plate and structural, trust me, you will never reduce the nickel and the copper percent. So if starting from this, you have to choose maybe internal low alloy, and then we use here 0. And it, as you see, we have still molybdenum and nickel. That's the game. You can add some of direct reduced iron to reduce these elements, but you have to take in account how many you're gonna add to reduce it. This is, for example, here we know that the chromium is alloyed. It's not as a residual element, but we still have a novium, just a little bit, but that's sufficient to increase and be in region that maybe the client won't accept. I'm gonna do this. It's not the perfect composition, it's not the perfect combination with scrap, but I want to show you the next step. The next step is take the scrap, and if you have different kind of scraps, heavy, and you have coarse, and you have fine, you have to combine. If you remember for your classes, the fine scrap used to be at the final of the bin. You can add it in the basket. You make kind of sandwich. The fine scrap needs to be at the bottom. Then you add the coarse scrap in the middle, and then we add the rest to make that famous sandwich, like fine or very fine, coarse, and then very fine or fine scrap. And then we have the cost per metric ton using just scrap. Until now, we don't have the fluxes, we don't have the ferroalloys, we don't have the cost of the use of the electrodes, the energy, electric energy, the carbon, the oxygen. We just have the scrap cost. But we do have the temperature required, the steel rate, the mass required, the maximum time. If you have your heat at 1 hour or I don't know, 15 minutes, you can send it to the next stage. And the carbon dioxide emissions required, this is the maximum amount, the 20,000 kilos. They mark. If you don't, if you are higher than this number, definitely the heat it's not valid, and you have to repeat it. And the slag composition. See, by now, if you want to do it again, you don't like or you don't match the cost per metric ton, you can start over, but we're going to start the simulation because we want to know how it works. So, as in the reality, you have to open the roof, and if you maybe are as desperate as I am, you can increase the simulation rate and then add the first basket. If you have 1, 2, or 3, those are the ones that you have to add. You close the roof, and then you can start with the melting. The electrodes with very carefully, they go down and power on. You can add some of the ferroalloys, the raw material, the dolomite, lime, iron oxide through the heat, but you have to be in the power on state to do it, or all the scrap need to be melted in order to do that. And as you can see, you can find the unit cost for every raw material and the final cost after you add. I'm gonna do a second sample. I'm gonna add 800 kilos of dolomite, and now you see the cost, the cost for this raw material. I'm gonna increase the simulator rate just in order to finish this heat. Maybe it's not the heat for the competition, so sorry, we don't have all the highlights marked, but you can take in the simulator a sample from steel. You can see all the bands. This is very helpful now after you reach the perfect heat, you have to do it again. You have 150 opportunities in the steel challenge to do it. So if you have the perfect heat, try to save all the event log and use it again for the next hit in order to decrease the cost. That's the most important thing. You can ask for a chemical analysis and take a sample, but you can also see all the elements in the chemical composition, the evolution of the elements through these graphics, related to the steel and related to the slag, and also the power and temperature. Why? Because actually taking a sample, a steel sample, it is money. The time that the furnace is on, it's money. The time that you're using the electrodes is money. The time that you're using the carbon and oxygen injection, it's money. All of these features are adding to the final cost. So I just want to finish this heat. You can see that the carbon dioxide kilos are increasing as we continue in the heat. Oh my God. Okay, this actually it's good because now you can see that the electrode breakage it also happens here. I can tap the heat, but you have to control some of these features here in the simulator. You can take samples, as I mentioned. You can make additions. Actually, as you remember, we have the chemical composition of the steel with the scrap that we choose at the beginning of the heat. So use that composition to calculate the raw material or the ferroalloys that you're gonna use in order that you have as many, well, actually you have as many time as you want, but you have to consider that the maximum time is 1 hour 20 minutes. In the competition, they give you 5 minutes before and after this time, but you can actually change the simulator rate as you need it. If you're doing something like melting, maybe you don't have to be in 1x, or you can increase the simulator rate. But when you are adding or doing a specific activity, you can go when you are practically in live, right? This is the same time as we are talking right now. So we have to start again. Every heat has a number. This actually doesn't matter right now because I didn't produce the heat as I expected, but if you can do it again, and if we have a successful heat, that one is gonna be here available for secondary steel making. So for the competition, every heat that you have here, you can use it here just in the secondary steel making just one time. You can use it more than one. That's important because I do recommend that using the electrical furnace start to produce a lot of heats. Try to reduce the cost in the electric arc furnace process, and then when you have managed this station, then start to use those heats for the secondary steel making process. And in that case, now you are perfectioning or doing your best in the another station. I forgot about the time. I got so excited and I continued playing. So I'm gonna give this time to all the questions that you may have. And again, thank you so much, Suez University, for the invitation. And to all of you that are listening to me right now, thank you for attention.
Thank you, Doctor. We have a question from Dr. Hisham Saad. He says, are we near to achieve zero waste and zero emission concerning iron and steel making?
How can we achieve the zero emission? That's the question.
No. He says, are we near to achieve zero waste and zero emission concerning iron and steel making?
They do take in account the emissions of the zero waste, but actually that's part of the cost. In the simulator, they for I don't know 2 years from now they start to taking into account the carbon dioxide emissions, but definitely maybe you won't find here the perfect heat to reduce the zero waste, but at least you can get the importance of the using of the conscious of the using of the right raw materials to produce the best, the not the best heat, but the lower cost per heat.
Thank you very much, Dr. Monserrat.
I'm just gonna show. Sorry, I'm gonna show my email, from my institutional account and my LinkedIn. If you have more questions, if you want to do it in English, but in written English, if you want to do it in Spanish, those are just the two. Sorry, the languages that I know. But if you want to write a specific question, don't hesitate and reach me at LinkedIn or at my personal number of my email. And thank you for all your time to this presentation.
Thank you very much. Here we have reached the end of the conference, hoping that you have obtained the desired benefit from this conference and enjoyed what was presented during it. Thank you very much for your commitment and presence. And I have to thank the great professors who honored us with their great experience and their great sessions today. Thank you Dr. إيمان المحلاوي, Dr. عبد الرحمن ببريك, Dr. رافي كومار, Dr. عبد الله الحزيم, Engineer أشرف حنا, Dr. Benjamin Hutton, Dr. Monserrat Sofia Lopez, and of course, Dr. Karim Badr. Thank you all. Also, I want to thank all MA Suez family for their great effort and our partners for supporting us during last days. Thank you very much. We will send a feedback form on our groups and hope you will share your suggestions and comments with us. Also, for other technical and non-technical events, please follow us on our pages on Facebook, LinkedIn, and Instagram. Thank you again. You can leave now.